welcome to my channel. So in this video I'm going to cover the solution to this question, and also at the same time I'm going to briefly go through the general steps we should follow in the real coding interview. So we are going to solve this problem and do some live coding here, and we are also going to cover the procedure in a coding interview. So before we start the real content for today, I would really appreciate that if you can help subscribe this channel, because it can help this channel to grow. So thanks a lot. So let's read through this problem. So remember, the first step, always try to understand the problem. If there's anything unclear, don't be shy to ask any question, and also at the same time think about some edge cases. So there are total this number of the courses you have to take, and labeled from 0 to none courses. So you're given an array of prerequisites where prerequisites I is AI BI, indicates you must take the course BI first if you want to take the course AI. So BI comes before AI. So for example, the pair 0, 1 indicates that you must take take course 0, you have to first take course 1. Okay, so return true if you can find all the courses, otherwise you're going to return false. So those are the examples, and let's see the constraints. It says the none course is never going to be 0, so it's between 1 to 100k. So the prerequisites can have anywhere between 0 to 5,000, and the length is equal to 2. Okay, so it seems like there's no illegal inputs here. So okay, so all the prerequisites are unique. Okay, that's good to know. So it seems like there's no such edge cases worth considered based on the constraints. So let's see how to solve this problem. So it's a pretty obvious solution to use topology sorting to solve this problem. So how to use the topology sorting? So we need to so you know that in the graph, in the directed graph, we have the in degree for each of the node. So first of all, we need to go through every of the edge, which is the prerequisites, and then record down the in degree of each of the node. So in degree, let's say I have a map from the node index and to its in degree. And then we are going to we also need to have a map from the node index to its corresponding neighbors. So the neighbor, so it's like the neighbor nodes. So the neighbor is defined as so for example, let's say we have prerequisite AI to AI BI, so we must take BI before taking AI. So there is an edge from BI to AI. So in this case, the node index is BI to so the value is list, at least must contain AI. So that's the two things I want to have, and the other thing I want to have is a queue. So the queue is going to have the node index. So first of all, we are going to push the node index with in degree as 0 into the queue, and every time we try to pop one node from it, and based on the map, the node to its neighbor map, you're going to find its neighbors, update the in degree, and then if any of the node has in degree as 0, then we are going to push into the queue. So that's pretty much how we are going to solve this problem. So essentially, what is the runtime for this? So the runtime would be, I would say it is O. Let's say there are n nodes and e edges. So let's say n plus e, because we need to go through every of the. So it's like for the first one, we build the in degree and this map. It is going to take OE, and then for the queue, we need to put everything with in degree at 0. Okay, yeah. So I would say, and every time we just pop it and we go through the neighbor nodes, so it is going to be O n plus e here. So actually, we also need to have another thing, which is visited.
So this set, which is called visited, to record down which course we have already visited there, so that we don't need to add that into the queue again. So having said that, let's start to do some coding work. So for coding, please take care about the correctness of the code, the readability of the code, and also don't be too slow. So the first thing I would say is to have the map of the integer thing. So this is integer. This is node integer. So let's put everything into it. Courses dot. Let's say that just I is equal to 0. Smaller than courses plus I. So node integrate dot put the course I with integer as 0. So this is the initialization of this. Then we are going to have the map, which is the graph map. So I'll say it is the integer to the list of the nodes, or let's have it as a set. So let's say I have a set of the integer. So this is the graph, and initialize it. Yeah. So this is let's say this is edge prerequisites. Let's say just call it prerequisite. So in from node is equal to prerequisite 1, and in the to node is from prerequisite 0. All right. So if the graph doesn't contain the key, so if the graph doesn't contain the from node, then we are going to add it. New hash set. Okay. And then we are going to say, okay, graph dot get from dot add the 2. So this is the initialization about the integer map and also the graph. And then we have the queue, which has integer. So the queue new linked list here. All right. So and it's called the visited stuff. So let's say the integer visited is equal to the new hash set, and at the end we expect that the visited is equal to num courses. The size of the visited is equal to the num courses. Otherwise, there is a circle within the graph. So we if there is a circle within the graph, then we are going to return false. Okay, so we have the queue here. Have the visited. So first of all, it's something like for everything node within node index integer dot key set. So if node integer dot get the node is equal to a 0, then it means integer is 0. Then we are going to push into the queue. So add it into node dot add into the add node, and visited is we are going to mark it as visited as well. So that's the initialization for the queue and the visited array. So then it is well, the queue is not empty. Well, the queue is not empty, so we are going to try to pop that. Try to pop the node from the queue, update and find its neighbors, update the integrate. If any of the node has integrate as 0, then we are going to push that. So let's say if okay, so this is like node is equal to queue.pop. For goes through all of its neighbors. I would say if it has been visited, not actually. So we shouldn't do it here. So this neighbor from the graph dot get or default. So this is get or default. Or if we can do it, if the graph, if not graph contains key node, then we continue. So in this case, we don't need to call this one. We just need to call get. So we call the get node, find out all of its neighbors. So you're going to update the integrate here, but if the neighbor visited contains the neighbor, then you're just going to continue. Otherwise, we are going to say node integrate dot put neighbor, node integrate dot get the neighbor -1. And if node integrate dot get the neighbor is equal to 0, then we are going to push that into the queue. Visited.added the neighbor. Alright, so now we have everything. And finally, we are just going to return visited. Size is equal to courses. So until now, we have most of the code in place. Let's depend on this platform to help us to do the debugging work. So it says class expected. That's okay. So I think yeah. So that's the thing I didn't do right. Okay, so this is some typos. So let's say 41. So 41 we have the key set node integrate key set. Okay, so it's got node integrate. Some typo here. Integrate. So the queue pop or just pull, I guess. Alright, so now it's good. Let's run some other test examples. So this one is wrong answer. Let's see why. The second one is we are outputting as true, but actually it should be false. So we have 0, 1 and 1, 0. So essentially, first of all, node integrate is initialize everything as with integrate as 0. Oh, okay. So actually, we forgot to update the node integrate here. So prerequisites node dot put this is the two nodes, and node integrate dot get 2 plus 1. So in this case, I think we should be good. Yep. Let's rinse to other test cases. All right, and then let's do a submission. Okay, so it seems like everything works well. And that's it for this coding question. And remember, don't forget to do some testing after you're done with the coding part. So that's it for this question. If you have any question about the solution or about whatever, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.